For this problem, we're going to solve a polynomial inequality. We want to solve the inequality x squared minus 10x plus 24 is greater than or equal to 0. If we go ahead and let f of x equal the left-hand side, x squared minus 10x plus 24, we're solving the inequality f of x greater than or equal to 0. To do that, we'll start off by finding where f of x is equal to 0. That is, we'll solve x squared minus 10x plus 24 is equal to 0. This is a quadratic equation. We can go ahead and factor this left side. We'll have x minus 6 times x minus 4 equal to 0. We'll set each linear factor equal to 0. X minus 6 equals 0. X minus 4 equals 0. And we solve these two linear equations. In the first equation, we'll get x is equal to 6. In the second, we'll get x is equal to 4. We'll use these zeros of our function f of x to divide the real number line into 3 subintervals. We'll go ahead and make up a table. In our first column, we're going to write down our headings for interval, a number in the interval, the value of f, and then our conclusion. We're using the two zeros to break up the real number line. Our first interval will be negative infinity to the first 0, which is 4. The next interval will be from 4 to the next 0, which is 6. And then we'll go from 6 to infinity. We pick a test value in each of these intervals. We can pick any value in the interval, but it helps to pick one that's an integer and something close to the boundary so that it doesn't get too big. In this first interval, we're going to pick 0. So that's a nice number to work with. The next interval, we're going to pick 5. And in the third interval, we're going to pick 7. We evaluate our function f of x at each of these values that we've chosen. We get that the function in the first interval, when x is 0, is equal to 24. In our second interval, when x is 5, the function is negative 1. And in the third interval, when x is 7, the function is equal to 3. What we conclude then is on the first interval, the value of the function is always positive. In the second interval, the value of the function is always negative. And in the third interval, again, the value of the function is always positive. We determine that by the value here. This is positive, this is negative, and this is positive. That tells us the sign of the function over the entire interval. Remember, we're looking for f of x to be greater than or equal to 0. This chart, or this table, will tell us where f of x is greater than 0. That is, where it's positive. So we have the interval negative infinity to 4 and the interval 6 to infinity where the function's positive. We also need to know where the function is equal to 0. We actually solve that right here when we set f of x equal to 0 to find our breaking points for the real number line. So we can say that f of x is equal to 0 at 4 and 6. F of x is greater than 0 on the interval negative infinity to 4 and the interval 6 to infinity. If we put all that information together, we can get our solution set for our original inequality as a set of values for x such that x is less than or equal to 4 or x is greater than or equal to 6. We want to write that in interval notation. Use negative infinity to 4 with a square bracket, or 6 to infinity with 6 having a square bracket as well. So there's our solution set for the inequality x squared minus 10x plus 24 is greater than or equal to 0.